want to show you how to adjust an X factor when you want to target a Y value and you have an equation. It means a model, a kind of Y equal function of X equation that is called a regression, a simple regression. It can be a linear regression, a quadratic regression, or a cubic regression. When you open the tool, you will find this Excel spreadsheet and table, which is pre-filled. What you have to know is that every cell in blue is protected. It means you cannot delete it. But if there is a formula, you can see it in the top bar here. Second thing, all the white cells, this is where you enter your own data, like the project title, My Process Improvement Project, as an example. You will tell us what is your Y measurement, what do you measure, your CTQ, critical to quality, can be a diameter, and then you will enter the date here. Let me unzoom it. The date here, let's say that we are in May, and your name, and what is the X factor that you are studying. It's a continuous X, could be pressure, temperature, everything you can study. Okay, let's say that now I have this data, and I have this equation, which is a simple linear regression with a R² value, which is not so good, but just for the example, we will use this value to show you how to adjust an X value when you want to target your Y value. So here your X is the pressure, and your Y value is the diameter. You can move a little bit this such that you can read it. So as you can see, we have a scatter plot, and we have a line here, which is this equation, Y equal 0.19x plus 13.628, the constant. And here below, you will find a white cell where you can set up a target for your Y value for your diameter. In my case, I enter 16.2.20, and when I enter this, there is automatically by the tool a resolution of the equation above, and they will say that the answer is 13.54 for pressure. And you can see it here displayed on the graph. So if you shoot for a Y target diameter at 16.2, this equation tells you to adjust your X factor at 13.54. This is for the simple linear regression. Now for the same Y, if you want to use a more complex model, which is a quadratic regression, with a little bit better R² value, you have two solutions, and this is indicated here. You have x1 adjusted at 9.79 and x2 adjusted at 16.72 for the same target, of course, which is 16.20. And same thing for the cubic model, which is much more complex but have a little bit better R² value, 31%. But as you can see, we have a complex equation with x cubed, x squared, and x coefficients and a constant. It looks like a sinusoid. And here you have three possible solutions for X adjustment for pressure for the same Y target value, which is 16.2. And the values you can find on the graph itself or here in these cells. X1 6.76, X2 adjusted 11.23, X3 16.13. It means that you have three options, three possibilities to adjust your pressure for the same diameter target, which is 16.20. Which one will you take? Will you choose? I think you will choose, if it's a question of pressure, the lowest pressure for security reasons, for example. So you see you have options, and this is what we call adjusting your X factor for targeting a Y value. Thank you.